Okay, so this is the second step in our checklist of figuring out how to factor polynomials. If you're watching this right now, you should have a firm grasp on how to factor out greatest common factor. Now, like any other math problem, you're basically trying to set things up into smaller problems and something that you already understand. So when you're looking at a polynomial, again, always try to take out a greatest common factor out of every single term. Okay, then you're going to count the number of terms. If the polynomial has 4 terms, what we're going to try to do is group the first 2 terms together, see if there's a greatest common factor there. Then we're going to group the second 2 terms together, see if there's a greatest common factor there. And then if that happens, hopefully there'll be another greatest common factor that we can take out front. Now, if you can understand this, the main part of factoring, which is factoring trinomials, will become very, very simple. So this is a very important step to look, to pay attention to. Now, the whole idea of this step is to create a multi-step greatest common factor problem. Okay, so here's a polynomial. We're going to try to factor it as far as possible. And we're first, just like any polynomial, we're going to check to see if there is a greatest common factor in every term that we can take out. Now this one has 4 terms. And if we look through, there is no greatest common factor that those 4 terms share. So we're going to move on and say, well, there's 1, 2, 3, 4 terms. Let's try and group it, the first 2 together and the second 2 together. Now when you do that, this is kind of an imaginary set of parentheses that you've put around each 2, and you're going to say to yourself, is there now, with just the 2 terms in the parentheses, is there a greatest common factor here? Okay, and if you understand how to do greatest common factors, you can easily identify that there is a y squared that we can take out of both of these. So we're going to take a y squared out, and we're going to be left with y plus 3. All right, now we're going to move to the second group that we came together with. And we're going to look and say, is there a greatest common factor out of these 2 that we can get? Now you should be able to see that a 4 will come out of both of those. And this is important to understand that we are taking a positive 4 out. So let's do plus 4. Say to yourself, what's left over? Well, that would be a y plus 3. Okay, now it should look very familiar as just some of the examples we were doing with the greatest common factor. We have 2 terms now. Here's the first one, and here's the second one. Both of these terms have a y plus 3 in them. So we're going to take the y plus 3 out, and we're going to be left with y squared plus 4. Okay, for the next example, we're going to go through our steps. The first step is always going to be check to see if there's a greatest common factor. And we look through all our terms, right? In this case, there are 4 of them. There is not any number or variable that we can take out of every 4 terms, or all 4 terms. So again, we're going to check to see if we can do 2 and 2. All right, now we group these together and we say what can come out of, or we're checking to see what can come out of both of the terms. Both of these terms have an x in them, so we're going to take out an x. We're left with 6 minus x. The second group, both of them have a y, so we're going to take out a positive y, and we're going to be left with 6 minus x. Now we have 2 terms, both of which have a 6 minus x that we can take out. And we're left over with an x plus y. All right, we're going to do another example here. And like always, we're going to check to see if each of the 4 terms has a greatest common factor. In this case, they do not. But we are working with 4 terms, so we're going to try, and I want to stress that we're just trying to group the first two and the second two to see if we can get some greatest common factors out. So we put some imaginary parentheses around each of these groups and see if we can take anything out. Now we're looking at this first group and nothing can come out. There is no greatest common factor here. There is on this second group, but we need to be taking out greatest common factors out of each of these parentheses, and since we can't do it in this one, we might as well just move on. Now, this does not mean that is non-factorable, okay? We are allowed to rearrange these terms and see if, see whether or not we can set it up so that we can group 2 and 2 and factor out greatest common factors. And in future 4-termed polynomials, we may group them in a different order, but that's going to be in the future. So as of right now, we're just worried about trying to group 2 and 2. So let's switch 2 and see what happens. And we're going to just switch these two just because they're right next to each other in the middle. So we're going to say 4x cubed plus 20x squared minus 15 minus 3x. And we're going to try and group 2 and 2 again. Now that we have this set up, we do have a greatest common factor we can take out of the first group and a greatest common factor we can take out of the second group. Hopefully this will leave us with another set of greatest common factors that we can factor out, but we can only check. So what comes out of 4x cubed and positive 20x squared? Well, 4 will come out, and also an x squared, and that leaves us with an x plus 5. Now let's move on to the next group. And remember, we are allowed to factor out negatives because we need exactly the same thing inside these groups of parentheses. So we're going to factor out a negative 3 because we want positives left over. So if we didn't take out a negative 3, we'd have something that we were kind of stuck with. So this is very, very important. What times negative 3 gives us negative 15? Well, that'd be a positive 5. What times negative 3 gives us a negative 3x? That'd be a positive x. And just like before, up here, we're allowed to rearrange terms as long as their signs come with them. Now, both of these are positive, so it shouldn't be a big deal. But we have 4x squared times x plus 5 minus 3 times x plus 5. Now we have a situation that you should feel very comfortable with. We have two terms here, each of which has an x plus 5, so I'm going to take that out front. And what's left over is a 4x squared minus 3. Okay, for the final example on grouping a polynomial with 4 terms in 2 terms and in 2 terms, right, the first 2 and the second 2. We have another polynomial here, and again, we're going to look to see if there is a greatest common factor out of all of the terms. Okay, in this case there is not, so we're going to move to the next step, which is trying grouping the first 2 terms together and the second 2 terms together. When you look at this, there is a common factor in the first group and a common factor in the second group. So we're going to try and see when we take out those common factors if we're left with something that we can factor further. So what comes out of the first 2 terms? Well, they both share an x, so we'll take that out and we're left with an a minus b. And what's common in the second? Well, a y. So let's take out a positive y and we're left with a b minus a. Now, be very careful because we cannot factor further if the common term that the common factor we're looking for is not exactly the same. A minus b is not the same as b minus a, so it's like we're kind of stuck right now. Now, there's little tricks that you can do to maybe make it happen. If you notice, this is a positive a and this is a negative a. And this one is a negative b, and this is a positive b. So these are actually opposites. So what we can do is try and see if we factor out a -1 out of this, if we're left with something that is common, common with the first group. So we're going to take out a -1, and this is kind of like a long drawn out way to do it. In the long run, you should be able to identify maybe a little bit more quickly what you want to have happen here. But if we take a -1 out, we're left with -b plus a. Now, if we rearrange these two, keeping the sign to the left with it, we would have x, a minus b. Now, right, this positive y times -1 is a negative y. And when we rearrange it, we have a minus b. Okay, so now we actually have a situation that we can move forward with because both of these terms have an a minus b with them. So we're going to take an a minus b out front, and we're left with an x minus y. So this is a little trick that you're going to really have to watch out for. This is going to show up quite a bit, where taking out a negative is going to be something that's going to be very helpful for you. Now, one of the ways to maybe avoid the confusion is if we had this rearranged at the beginning. But you're not always going to see something like that. And what I mean by that is if you look at this first one, we have an A and then a B, but then over here we have the B and then the A. So if we started off and rearranged these two, you might right away see that we need to take out a negative. But again, you're not always going to see that. And so you're going to want to be able to do all these little steps checking along the way. If you notice that the factors that you have are just simply opposites, take a -1 out of one of them and see what you have left.